Now seriously, whoever complains about having chocolate given to them? I would think no one, but there you go, Sebastian. Thank you so much for having me, and thank you, Sebi, for the awesome introduction. Today we're going to talk about PWAs. And I actually worked on this talk because of a very selfish reason. As a developer advocate, a lot of people would think that you get to party a lot. You go to a lot of after parties, speakers' dinners, it's a lot of fun. Other people might think that you actually run for their money, through a lot of money. We definitely think that we control the world and everything's perfect and it's under our fingertips. But what we actually end up doing is a lot of that. We spend a lot of time in planes and try to catch up with sleep. And it's not only in planes, but it's also on trains on our way to the airport and in hotels. And what these things have in common is absolutely horrible internet. And that's extremely frustrating when maybe 30% or 40% of your time is spent in those three places. You end up being very frustrated because you actually have to do your work. You have to prepare the night before a presentation like this one in front of all of you. I have to stress about the internet that doesn't work. So my goal today is to talk about progressive web apps and convince you, all of you, to go back home or back to your work and see how you can take your application and turn it into a progressive web app. And I'm going to start with an intro to progressive web apps, dive into some of the main concepts. We're going to look into how Angular can help us building progressive web apps, and then we're going to answer questions like which of the native APIs are available to us. And finally, we're going to understand some of the tools that are available to us. So what are progressive web apps? They are basically websites, normal websites, that can appear to the user like traditional mobile applications. Have that full experience of a full screen where you don't get a navigation bar and you can fully immerse into that application. But the most important part is that you also get to use that application when there's no internet. Another definition that I absolutely love is that they're just websites that took all the right vitamins. And keep in mind, you and I are the people that are feeding the right vitamins to our websites, to the apps that we're creating. And this is a definition coming from Alex Russell's website. And for those of you who don't know who Alex Russell is, he's a developer on the Google team. And together with his wife, Frances, they basically came up with the progressive web apps term. They coined the term. And they also came up with a list of 10 things that would make up a progressive web app. And we won't look into all 10 of them, but there's 3 that I think are absolutely important. The first one is part of the name. We have to build progressive application. And this progressive refers to the user experience. So think of this. You start maybe with a mobile phone that doesn't have the latest browser support. And it doesn't have the latest features. Your website should definitely work on that browser as well, should work for that user. But as the user kind of moves on and uses a better phone, it has better support for all the progressive web apps features, their experience enhances. So they get to install that application to their home screen, they get to have their assets cached even when they don't have internet and use those. So it's very important to keep in mind this progressive enhancement. The other thing that's very important, and it matters a lot to me, is the connectivity independent feature, where basically that means that users can use your app even when there's no internet, just like a traditional native application which you can open. And even though there's no internet, you can see the app shell. So that's like the basic of your app that doesn't necessarily render data, but it's still, you can still see something. You get some feedback. You don't get a dinosaur. And the other thing that's very important, because service workers are quite powerful, as we'll see later on, our applications need to be safe. We need to make sure that other third-party attackers cannot tamper with our content. So remember, progressive, connectivity independent, and safe. So how do we get started? Well, there's this thing called the baseline appiness, and we start with service workers so that we can cache our content. And then on top of that, we add the web manifest, which is something that will tell our browser that it's looking at a progressive web app, and it should prompt the user to install this application. And then everything needs to be delivered under a safe context. So service workers, web manifest, and delivered over HTTPS. So then what are service workers? They're basically proxies that sit between the web page and the network. And they can decide whether we're serving cached data to our users or we go over the network and make the actual request. And you can think of your web requests as planes taking off. And the service worker is the air traffic controller, which will basically tell us whether we should serve content from a cached resource or not. I highly recommend you check out this book by Dean Allen Hume, Building Progressive Web Apps. It's available on Amazon. It's really good. So from a diagram perspective, we have our user using the web page, and then we have the network, which is the dotted line, and our service worker sits in between our user and the network. And then on the other side, we have our backend, or we have something that gives us where we can retrieve the data from. It can be our own backend, it can be a third-party API, we don't care. And then we also have the cache, which sits right on the same side as the service worker. So the user makes a request, and then the service worker goes ahead and analyzes this request in order to figure out whether it should return data either from our API or from the cache. And it thinks about it, it works, and then based on the caching strategy that we've defined, it will make a decision. So we can have things like whenever we're looking at data that it's always changing, we definitely need to have a network-first kind of approach when it comes to caching our data or making requests. So we go retrieve data from our API, and then we return that data, and we return that to our user. But what about assets and resources that don't change that often, or that we've already retrieved and we know that we can cache them or there's no internet? What we do then is actually read that data from our cache. And that's actually super important not only for when you don't have internet, but it's also super important thinking of performance. So our applications can benefit highly from having a lot of the resources that are not changing cached. And this way we avoid that round trip to the server, which costs our user a lot of time and our application performance. And this goes back to Matthias' point about Angular I/O, which is a PWA. And we can see that there's tons of users using it, and that's perfectly fine. So we get that data from the cache, and we return it to our user. There's two things that we need to keep in mind about service workers. The first one is that it has a scope and a life cycle that we can tap into. And the scope refers to the domain that is going to that we're going to use to listen to those requests. So everything that is being every request that's being made to that particular domain, or the subdomain, is going to be intercepted by our service worker. And the scope of the service worker is where it's being defined. And one thing to keep in mind is that the scope of our web application or of our DOM, we cannot change that from our service worker. In terms of lifecycle, we can tap into the installing method or event. So we start with no service worker, then our service worker gets installed, and if everything goes okay, we're going to go into the activated state, and that means that we're going to intercept all those requests that are under that domain. Or if we were caching some resources and an error happened, that means that it's going to go into the error phase And once we load that page, it's going to try again to install the service worker. Yeah, and from activated, it will go into idle, terminate, or listen to fetch events. So the first thing that we need to do is actually go ahead and register that service worker. But in order to do that, we have to check whether our browser supports that service worker or not. And most modern or all modern browsers right now, they do support service workers. But if you think that there's users that are using older versions of the browser, then you definitely need to check that the service worker is supported. And once we've registered, we can actually tap into those events. So we can tap into the installation event, and from there, we can go ahead and cache assets for our user so that we can serve them in case they don't have network connectivity. Or, like in this example, we can serve them whenever someone tries to request a cat picture image. We're going to say that we're going to turn you into a dog person. So we're not going to return a cat picture, we're going to return a dog picture. You can see that on line 17, I hope this is clear, kind of. We're basically checking if the URL is requesting for a dog image, and then we're going to respond with a different resource. And this is what I meant by service workers are very powerful. So all this code can be executed, and we can do everything. We have access to cache, we have access to local storage. So if we didn't serve this under HTTPS, someone could tamper with our service workers, and they could steal our data, and they could display other information to our user. If you wanted to test service workers, you can do that using Chrome. We have this application tab in Chrome Tools where you can basically inspect whether your service worker has been installed or not. You can also see its status, when it's been installed, what it's listening to, and you can even test it by checking the offline tick. You will be able to see whether the cached content is returned or not. The other thing we can do is, because service workers are JavaScript files, we can debug them just like we would normally debug JavaScript. So you can add breakpoints, and you can go through, step through those lines and understand whether something like what's the URL that's being cached. If we didn't want to install this, if we didn't want to use the service worker anymore, we could also uninstall it, and this is how you would do it. So there you go. We have connectivity independent. We do have fresh data because we are able to update within our service worker the data that we've cached. And our application is discoverable by default because we're looking at a web application which can be searched over the internet. It has a URL. That's pretty cool. That wasn't a lot of work, right? The next thing that we need to look into is the web manifest. And this is a file that will tell our browser that our application is a progressive web app and it can be installed by our user. And this is useful because that means that our user will be prompted to install that application. And this is how it looks like. We can specify things like what's the icon that's going to be displayed on our phone's screen, what's the name that's going to be displayed there. And also another important thing here, at the start URL, that's where we tell what URL our application is going to open. And we're using here UTM source. And for those of you who don't know what this is how we can gather analytics about how the users have accessed our application. And this is useful in the context where you want to figure out how many people have actually installed the application on their home screen and how many people have opened it using that particular icon. And you can think of this further. If maybe 80% of our users are using that particular app, that means that it's a huge success, right? And you can work further to improve their experience. If it's only 10%, that means that there's a lot of work to do so that people feel compelled to use that application. So with the web manifest, we've made our website installable on a mobile phone or on a desktop. So what about Angular? where does Angular help us with this? Well, if you're using the Angular CLI, it will give you out-of-the-box support for progressive web apps. And we can easily just create a new application, and then we can add PWA features to our Angular application. It's as simple as that. And what this will do for us is it will create a new set of files, or it will update them. And it will, in our build, in our Angular.json file, it will enable the service worker flag, which means that our application will build our service worker as well. And then we're also going to include the manifest.json in our assets. And the manifest.json file has been generated by the Angular CLI. And then in our module, we register that service worker. And all of this is done by Angular for you. And finally, we don't have to write all that service worker code. We don't have to implement the caching strategies ourselves. Angular is doing that for us. It has a file, an implementation of the service worker. And this is the configuration where we actually tell them which are the files that we want to cache and which are the strategies that we want to use, but we don't implement them ourselves. So Angular does all the heavy lifting here. You can see that I am basically caching what is called the app shell, so that's the app without the data, with a prefetch strategy, and then all the assets, I'm lazy loading them. In order to test our application, we need to build for production, because we don't want to test service workers in our development mode, because that means that they will constantly cache those resources, and that would be really bad for our development experience. Imagine not having your application change because it's being cached by a service worker. So we want to run this for production, and then this will generate the service worker that I was mentioning earlier, and it will add the configuration, the runtime configuration we've defined. And then we can use Lighthouse again to test whether our application is progressive or not. And it's using a checklist that's been defined by developers out there. And you will see that it will give us a score, which is from 0 to 100, and our target is to be 100% progressive. But in our case, we weren't 100% progressive. So why is that? I was hoping that Angular would do everything for me. Well, it turns out that I have to serve my content over HTTPS, as I was mentioning earlier. And in my case, it was easy to do that with Azure, because I know I only have to click a button, and then it serves all the content over HTTPS. If you're running in your local, you could also use tools like HTTP Server and install certificates, and then start them using HTTPS. So now we have 100%. Woohoo! That's awesome. That's your goal, your task. What about PWA versus native? Probably you have this question, like which are the APIs that are available for us, like on the mobile in the web API? Well, if we think from a hardware perspective, geolocation, camera and microphone are all supported across the board on all browsers. We have access to Bluetooth as well in the web API, only in these two browsers, Chrome, and the other icon, for those of you who don't know, it's the Samsung Internet browser. So if you have a Samsung phone, you can use that browser as well. These other three features, NFC, which is the tapping capability, ambient light sensor, which allows our phone to kind of change their brightness depending on the light outside, and proximity, which is to figure out whether when we're speaking at our phone to lower the volume or make it higher, they're not supported by most browsers. But in terms of software, push notifications, save to home screen, full screen, offline, clipboard, they're all supported by major browsers, except for some. So Safari has support for service workers, which is awesome. And you can still save to home screen, but you have to do that manually. So you have to go into the options and click Save to Home Screen. But it's almost there. Like, we have a lot of support there. What's not supported is APIs that I think are absolutely sensitive. I wouldn't want web applications to have access to my contacts and calendar and calls. What if my website can answer my phone? That wouldn't be cool. You can also install applications from app stores, from the Windows app stores, but also from the Chrome app store. And then the tools that are available, we've already seen the Lighthouse. There's also PWA Builder that helps you build your service workers from scratch and your manifest.json file. Workbox is a tool that will give you access to more fine-grained control to service workers. And then service worker toolchain is something that's been created by Pinterest team, and you can test your service workers easily. A showcase of PWAs that have been implemented in different frameworks together with their scores and where they're deployed is available at Hacker News PWAs. And then the Angular CLI has helped us a lot. So I encourage all of you to build progressive web apps, to turn your applications into progressive web apps, because there's a new way to deliver amazing user experiences on the web. Thank you very much.